Okay, looking at the review, we're looking at number 1. ABCD is a parallelogram. If DAB is 115, DAB is 115 degrees, then BCD, which is this angle right here, is what? Well, you remember one of the rules of a parallelogram, opposite angles are congruent. So if that's 115, that's 115. The answer is D. Number 2, ABCD is a parallelogram. So CDA, this angle right here is 66 degrees. The measure of BCD is this angle right here. Well, consecutive angles are supplementary. So 180 minus 66 will give you 114, which is our answer here. Rules of parallelogram, opposite angles are congruent. Find the measure of an interior angle of a regular polygon with 14 sides. You'll recall our formula for that, where we take the number of sides, subtract 2, multiply that times 180, and that tells us equals the sum of the interior angles. Now this says measure of uninterior, meaning 1, so whatever we get, we're going to divide it by n. So this is 14 sides, so 14 minus 2 is 12. 12 times 180 equals, let me do that real quick. I don't have my notes in front of me. 12 times 180 is 2,160. So that's the sum of all the angles. Now we have to divide that by the number of angles, which again was 14. So 2,160 divided by 14 equals 154.3 when you round it to the tenths place. So the answer is C. Okay, now the next one, find the measure of each exterior angle of a regular hexagon. Hexagon has 6 sides, and you'll recall that when you add up all the exterior angles of a polygon, it equals 360 degrees. So if this has 6 sides, it has 6 exterior angles, so we divide 360 by the number of sides, which would give us 60. If that was an 8-sided, if that was an octagon, we would take 360, divide it by 8. If it was 10-sided, 360 divided by 10. The exterior angles always add up to 360 on a polygon. All right, number 5. What is true about this? So it's a parallelogram. So if it's a parallelogram, let's look at segment AD. So CG, opposites, would it be congruent to CG? Well, look at CG. CG doesn't make a whole lot of sense. It's this segment right here. First of all, they're not congruent, so that's out of the question. What about BC? This segment right here. Actually, those would be congruent because, would it be because of what it says? Diagonals of parallelograms bisect. Well, neither of those are diagonals and they're not bisecting, so that's out. But look at C, BC. They're congruent because opposite sides of parallelograms are congruent. That's my answer, C. And now CG, no, CG is not going to be congruent to that. Number 6, trapezoid. Again, we have a mid-segment right here, which is 36. You'll recall the mid-segment formula where we add the bases. ML is my variable, my unknown, so I'm going to add x, that's one base, plus 32, my other base, divide it by 2, and that's going to equal the mid-segment, which in this case is 36. Get rid of the fraction, multiply by 2, cancels that out. So x plus 32 equals 72. Subtract 32 and we find that x equals 40, which is D in this case. And number 7, the perimeter of this figure is 36. So we need to add all three sides and set that equal to 36 in order to find the value of t. You can't read it there, but I'll tell you this first one is 2t. The second one is 2t plus 2. And the last one is 2t plus 4. Okay, add all the t's up, combine like terms, and we get 6t plus 6 equals 36. Well, subtract 6 from both sides and you get 6t equals 30. Divide by 6 and t equals 5. It's not our answer because now we have to plug it into each of those. The first side was 2t, which means it's going to be 2 times 5, which is 10. The next one was 2t plus 2, which would be 10 plus 2, making that 12. And then 2t plus 4, which would be 10 plus 4, making it 14. Which would mean my answer would be D. Okay, number 9. We're talking about a parallelogram here. Are the diagonals congruent? The answer here would be, it says that it's a parallelogram. Are the diagonals congruent? Well, we would have to do the distance formula. And the answer would be yes, the diagonals are going to be congruent in this case because even though a parallelogram, the diagonals are not always congruent, in this case they are. And how we would do that is we would find the points. The points for B would be 6, 8. And we would have 0, negative 2. Then we would have 0, 0, 6 here, and 8, 0. I'm sorry, 6, 0 here. So distance formula for the first diagonal, this one right here, we would take the square root of 6 minus 0 squared plus 8 minus negative 2 squared, which gives us 6 squared plus, that would be a negative 2, 10 squared. So 36 plus 100, 136. Now if I do the same thing with the other diagonal, I would take, now we're looking at this, I would say, so I would do this one and I would have my 6 minus 0 squared plus 0 minus 6 squared, which we still end up with 6 squared plus negative 6 squared. 36 plus 36 is square root of 72. So are they congruent? No, they are not, because the diagonals are not the same. Are not congruent. D. Okay, the next one, what we're looking at on this first section is the slope. Here we're looking at the distance. So we're going to use the slope formula and the distance formula. So what we have is some type of quadrilateral, and actually it's a parallelogram. So we have A, B, C, D. Determine where the figure is, determine if it is a parallelogram. So the way we would do that would be to prove that slopes were congruent, or slopes were the same, that they were parallel. So if I take a look at the measure of the slope of AB, we're looking to see if it's parallel to CD. So for AB, remember for slope we do y's over x's, so 1 minus negative 9, should be 9, over 10 minus 3, which we get 10 over 7. It's the slope of AB. The slope of CD, I'll do that over here on the side. Slope of CD would be 10 minus 3 over 4 minus -9, which would be 7 over 13. Are those two slopes the same? They are not, therefore it's not parallel. Now that means that this is not going to be a parallelogram because opposite sides have to be parallel. So the answer is no, but what is the reason why? Is it because opposite sides are not congruent, do not have the same slope, or just they do not have the same slope? We have to check the distance formula on these two segments as well. So let's do the distance of AB. 10 minus 3 squared plus, again we're looking at points A and B, 1 minus -9 squared. We end up with 7 squared plus 10 squared. 49 plus 100, radical 149. And we'll do the same for CD. CD would be 4 minus -9 plus 10 minus 3. We end up with 13 squared plus 7 squared. Well, we know these two are not going to be congruent. We end up with a radical 218. So why is this not a parallelogram? It's not because the opposite sides are not congruent and they don't have the same slope. A. Number 10, quadrilateral ABC is a rectangle, so if ADB, this angle here, is 4W plus 56, and CDB, the other angle down here, is 8W plus 22. Now remember, the angle is a right angle, so 8W plus 56 plus, sorry about that, 8W plus 22 plus the other angle, 4W plus 56, those are going to add up to equal 90 degrees. They're complementary. 12W plus 78 equals 90. Subtract 78. 12W equals 12. And we find that W equals 1. So the question here is CBD. That is this angle. Well, this angle is going to be congruent to this angle because they're alternate interior angles. We have parallel lines with the diagonal being the transversal, so those are equal. So we're going to plug in 1 for 4W plus 56. So 4 times 1 plus 56, we get 60 degrees. A. Okay, the problem below. If YZ is 12, what is AB? Well, remember, all the angles are congruent in a rhombus, so it's also going to be 12. No work on that one, just knowing the rules of a rhombus. Number 12, which of the following statements must be true about this Venn diagram? Quadrilaterals are not rhombi or rectangles. Well, they are. Four-sided figures are all quadrilaterals, so they are. So A is not the answer. All rectangles are rhombi. That is not correct. There are some, if you'll notice, they actually just overlap a little bit. So some rectangles are rhombus and are rhombi, and some rhombi are rectangles, which is what statement C says. That's the correct answer. Because look at D. All quadrilaterals are rhombi and rectangles. Not true. We have kites, trapezoids. Those are not rectangles or rhombi. Alright, now this trapezoid, a little bit simpler than the last one we had. We take the two bases, we add them up, and divide by 2. So 19 plus 27 equals 46. Then we take half of that, which is 23. And that's my answer. The opposite side of a window frame are congruent. So opposite sides are congruent. Which additional piece of information would verify that the frame is a rectangle? Well, we would have to prove, if you recall, the diagonals to be congruent. BD has to be congruent to AC, which would be B. Excuse me. Number 15. Mr. Hazelwood's constructing a walkway through his rectangular garden. The walkway runs diagonally as shown in the diagram. Which is the closest to the length of the walkway? Well, opposite sides are congruent in this rectangle, so this side is also 15. We have 90-degree angles, so we want to find the value of the walkway. Well, this is a right triangle with a missing side, so we're going to use the Pythagorean theorem because the walkway is the hypotenuse here. 15 squared is 225 plus 24 squared, 576, which when you add those together you get 801. To solve for x, square root both sides, and c is roughly 28.3, which is answer B. Number 16, to the nearest tenth on a square inch, what is the area? This is a tough one because you recall in the parallelogram we find the area by measuring the base times the height. Well, the height is not 10 here because that's the slant height. The height would be this distance right here. Well, we don't know what that height is, but notice what we create by doing that, a 30, 60, 90 triangle. So we can find that if I go hypotenuse to short leg, it's half, so this segment is 5. If I go short leg to long leg, that is 5 radical 3. So my answer is going to be 15 times 5 radical 3, which is the height. And when I do that, I get a product of 129.9 when I round it. Okay, what is the point of intersection of BD and AC? Well, what we have here is a rectangle. So what we need to do is we need to find the midpoint, or what we have. The slopes are all congruent, so it's a parallelogram. So we have to find the midsegment because they bisect, the diagonals will bisect each other. So the midpoint of AC is going to be the x's added up, 7 plus 1 divided by 2. And the y-coordinate will be 7 plus 1 divided by 2, which is 8 over 2, and we get 4, 4. If we do the same thing for BD, we take 1 plus 7 divided by 2, and the y-coordinate will be 7 plus 1 divided by 2, which we get the same thing, 4, 4. That is the point of intersection. Number 18, what are the values for x and y? Well, they form a linear pair, don't they? Don't these form a linear pair? So basically, 180 minus 89 will give us x, which is 91. And then this is a linear pair. 180 minus 82 gives us 98 for y, which is why the answer is A. Alright, in the drawing, regular polygon is partially covered by a rectangle. We need to, basically the question is, what polygon has an interior angle of 135? So n is my number of sides, that's what we don't know, but when I subtract 2 and multiply that times 180, and then divide by the number of sides, we get an interior angle of 135. So now we have to solve for our variable. Get rid of the fraction by multiplying by 9, and distribute our 180. So we end up with 180n minus 360 equals 135n. Solve for n, subtract 135n from both sides. We get 45n. Add 360 to both sides. We get 360. Divide by 45. 360 divided by 45 is 8. That's an octagon. Okay, number 20. What is the value of x in the trapezoid ABCD? Well, opposite sides of this, what ends up being formed here is a rectangle, doesn't it? This is a right angle, which means opposite sides are going to be congruent. So 20 equals 2x plus 6. Subtract 6, and x equals 7. when tiles are tessellated in a plane, what angle measures? Basically that means when you have a tessellation, you have a point, how many angles are consisting of one full rotation around that point? Well, that's going to be 360 degrees. And number 22, quadrilateral QRST is placed in a coordinate grid, and there we have it. What coordinates for S make QRST a parallelogram? Well, this one, we could use distance formula and use variables and all that, but stop and look a second. The bottom, from here, the X starts at 0, and it ends at 8. So it has a distance of a length of 8. Opposite sides are congruent with a parallelogram. So if my slope has to stay the same, that means my y-coordinate is going to be the same for this horizontal line. So we're going to maintain that 6, but it's 8 units over from 4. So 4 plus 8 is 12. So my new point there would be 12, 6. We added 8 to the x-coordinate, and we left the y-coordinate the same. Okay, 23, this is a rhombus with EBC equaling 36 degrees. What's the measure of DAE? DAE, that's this angle right here. Well, if you recall in a rhombus that the diagonals bisect the opposite angles, which means that angle is congruent. And if that angle is 36, well, that angle is also 36. We also know that diagonals form right angles. They are perpendicular to each other. So if we're looking for this missing angle, we just have to take 36 plus 90, which is 126, and subtract it from 180. And we get 54 degrees. That's the missing angle. Okay, number 24, rectangular rug. This one's kind of a tricky question. I actually had to think twice when I first saw this. So we have a rectangle. Uh, 24 feet by 10, and a rhombus is inside, joining each mid-segment. What's the length of each side of the rhombus? Well, what I did is I drew these horizontal and vertical lines. This is going to have a length of 12 because it's half of the whole length across this rectangle, and this is going to have a length of 5. So what we end up is a triangle with 5, 12, and then x, with x being one side of the rhombus. Now, we could do Pythagorean theorem and get our answer, which is 13, or we could remember that 5, 12, 13 is a special triple. Number 25. ABCD is a parallelogram. Which of the following piece of information would suffice to prove that it is also a rectangle? Remember, this one would definitely be, the diagonals would have to be congruent. AC congruent to BD, which is A. 26 is a parallelogram. Which of the following must be true? Well, if it's a parallelogram, do AB and AD have to be congruent? No. AC and BD, do diagonals have to be congruent? No, not the case. A and D have to be congruent, the angles? No. But opposite angles are congruent in a parallelogram, which is why the answer would be D. Alright, this is kind of one of those questions talking about a tessellation. If we're talking about, and let me zoom in here, this point from here all the way around has to be 360 degrees. So we're looking for the value of x. Can we find the measure of this interior angle? Well, it's an octagon. So we subtract 2, multiply it times 180, and divide by the number of sides, which is 8. 6 times 180 is 1080. And when we divide that by 8, we get 135. So this angle is 135. What we have here is an isosceles trapezoid. So we have to find the measure of this angle, which is going to be congruent to this angle. 55 and 55 is 110. All four angles have to add up to 360 in a quadrilateral. So those other two angles have to add up to 250. Well, they're congruent, so we can divide it by 2, and so it has to be 125. So this angle is 125. So for the whole thing to add up to 360, I have 135 and 125, which adds up to 260. I have to subtract that from 360 to find the measure of x. I get 100, x equals 100. Alright, now we get that number 28. This is a tough one. There's a lot of work on this one. We're given the points. We have to determine whether it's a parallelogram or not. And whether, if it is, whether it's a rhombus, rectangle, or square, or all three. So here we have our figure A, B, C, D. We're going to find the distance in these and then the slope in these. So distance formula for AB, remember we subtract the x's, square it, and add the y squared. So we're going to have negative 2 plus 2 squared plus 6 minus negative 1 squared. And when I do the work there, you should get radical 49. Okay, do the same thing for BC, which when I do BC, I get negative 2 plus 9 squared plus negative 1 plus 1 squared. When you do that, you should also get square root of 49. And the next one, you should be looking at negative 9 plus 9 squared plus negative 1 minus 6 squared, which you get radical 49. And the last one, you should be looking, your distance formula should look like negative 9 plus 2 squared plus 6 minus 6 squared, which gives you radical 49. Notice, they're all congruent. That means this is a rhombus and it's also a square. Well, we don't know if it's a square. Let's take a look at the slopes and see what we get there. When we do the slope AB, we should get 6 plus 1, or actually I'll do that where we go 6 minus negative 1 over negative 2 minus negative 2. And we end up with 7 over 0, undefined. The next one, BC, we should get negative 1 minus negative 1 over negative 2 minus negative 9. Which when you do that, you should get 0 over 7. CD, negative 1 minus 6 over negative 9 minus negative 9, which you end up with negative 7 over 0. Again, undefined. And the last one is 6 minus 6 over negative 9 minus negative 2, which ends up being 0 over negative 7. Slope of 0. So, they are opposite reciprocals of each other. Therefore, not only are they parallel, opposite sides are parallel, but they are also congruent. All sides are congruent. Now, we need to determine whether or not it's a rhombus or a rectangle. by finding the slope of the diagonals and the distance of the diagonals. Like I said, this is a long problem. So if I'm looking at BD, the distance formula is going to be -2 minus -9 squared plus -1 minus 0 squared. When you do that, you should get radical 98. I did something wrong there. BD, that should be a 6, not a 0. That's why. And then when I do the distance for AC, you should get -2 minus -9 squared plus 6 plus 1 squared, and you get radical 98. So they're congruent, diagonals are congruent. We can say it's a rectangle. Now if it's it'll be a rhombus if the diagonals are congruent. I'm sorry, if the diagonals are perpendicular. So let's check that out. So for BD, the slope is going to be 6 minus -1 over -9 plus 2, which is 7 over -7. Slope for AC is going to be 6 minus -1 over -2 plus 9, which is 7 over 7. They're opposite reciprocals of each other. One's positive, one's negative, and 7 over 7, the reciprocal is going to be 7 over 7. So yes, they are perpendicular to each other. So not only is it a rectangle, but it's also a rhombus. And if it's both, it's a square. That's how we know if it's a square or not. All right, looking at 29. Use the theorems for interior and exterior angles of a polygon to find the sum of the measures of the angles in a 74gon. So the sum of the measures. So we're going to use our formula 74 minus 2 times 180. So that's basically just 72 times 180. When you do that, you should get 12,960. Okay, the number of sides in an n-gon if the sum of the interior angles is 2,700. So we don't know the number of sides, so n minus 2 times 180 equals the sum, which is 2,700. Distribute the n, we get 180n minus 360 equals 2,700. Add 360 to both sides, and you get, I'll do it down here, 180n equals 3,060. Divide both sides by 180, and n equals 17. Okay? The next problem, be careful because it says exterior angle. The exterior angle measures 40 degrees. So basically, remember, all of the exterior angles of any polygon are going to add to 360. Divide it by the number of sides, which we don't know. That's what we're looking for. And you get 40. So how do we do this? Well, we get rid of our fraction by multiplying by n. And we get 360 equals 40n. Divide by 40. And n equals, number of sides is 9. Again, all we really did is divide 360 by 40 degrees to find out how many sides it was. Alright, here, we're going to go through this fairly quickly. Decide whether each statement is always true, sometimes true, or never true. So let's check this out. Polygon is equiangular and equilateral. That is always true. Consecutive angles of a parallelogram are supplementary. Yes, that is always going to be true. Diagonals of a rhombus are equal in length. the diagonals of a rhombus are not equal in length, but sometimes they are. If it's a square is a rhombus, but a square also has diagonals that are congruent. So sometimes the diagonals of a rhombus are equal. A rectangle is a square. Sometimes that is true. Sometimes a rectangle is a square. All parallelograms are quadrilaterals? Yes, that's always true. A parallelogram is a four-sided figure, which are all quadrilaterals. All rectangles are parallelograms. Yes, they fall under the umbrella of a parallelogram, so they are, all rectangles are parallelograms. A quadrilateral is a parallelogram. That is sometimes true. Some quadrilaterals are parallelograms, but not all quadrilaterals are parallelograms. A rectangle is a rhombus. That is sometimes true, you know, with the square. If it's a square, then it's a rectangle, but it's also a rhombus. Okay, if the diagonals of a quadrilateral are equal, then the quadrilateral is a rectangle. That's always true. That's how we prove rectangles. Diagonals are congruent. If the diagonals of a quadrilateral are perpendicular and bisect each other, then the quadrilateral is a rhombus. That again also is true. That's how we check a rhombus. The diagonals of quadrilateral divides the quadrilateral into two congruent triangles. That is not always the case. That is sometimes the case, for instance, if we're dealing with rectangles or squares. Or rhombus. If the diagonals of a quadrilateral are equal, then the quadrilateral is a parallelogram. That is sometimes true, but not always true. It's true if it's a rectangle, but if it's not a rectangle, then it's not true. For instance, a rhombus is a parallelogram, and the diagonals are not congruent in a rhombus, always. If the diagonals of a parallelogram are perpendicular, then the quadrilateral is a rhombus. That is always true. That's how we test a rhombus. Similar to a previous one we looked at. Diagonals of a parallelogram bisect each other. That's always the case. One of the properties of a parallelogram. The opposite sides of a parallelogram will have different lengths. Is that true? Actually, the opposite sides of parallelograms are congruent. That is never true. Parallelograms are rectangles. That is sometimes true because some parallelograms are not. Some are rhombi. Okay, let's look at number 31. These are all going to add up to 360 degrees. It's a quadrilateral, so we have to take 5x minus 10 plus 5x plus 20 plus 4x plus 3x plus 10 and set it equal to 360 degrees. Combine like terms and you end up with 17x plus 20 equals 360. Subtract 20 and you get 340. Divide by 17 and x equals 20. Okay, a regular octagon, that means 8 sides minus 2 times 180. This is going to give us the sum. Basically 6 times 180, which is 1080. That's the sum of all the angles. Now we have to split it amongst the 8 angles, and when we do that, we get 135. So that's what y is equal to. All right, number 32. Same situation here. They all added up to 360 because it's a quadrilateral. So 90 plus 90 plus 142 plus x equals 360. Combine like terms and you end up with, what do we end up with? 322 plus x equals 360. Subtract 322 from both sides and x equals 38. The next one, this is not a quadrilateral, this is a pentagon. So instead of adding up to 360 degrees, it's going to add up to 540. How do we know that? We could do 5 minus 2 times 180 which is 3 times 180, which is 540 degrees. So we have to combine all the like terms. 2x and 2x is 4x. 90 plus 110 is 200. 200 plus 84 is 284. Set it equal to 540 degrees. Subtract 240. Divide by 4. And x equals 64. Next one, quadrilateral. Add them up. They're going to add up to equal 360 because it's a quadrilateral. So 6x plus 90 equals 360. Subtract 360 from both sides. Divide by 6, and x equals 45. Okay, next one, we're going to find x. This has 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 times 180. When we do that, we end up with 720 degrees. So all of these angles have to add up to 720. Well, we don't know what this angle is right here, but it's congruent to this angle, so it's 3x. So I have one number, 90 plus 4x, 6x, 9x, 11, 14x. So, okay, 720 that should look like, or should say. So subtract 90 from both sides, and 14x equals 630. Divide both sides by 14, and x equals 45. Okay, next one, it's a regular hexagon. We have to find all of them. Well, to find out what the regular hexagon, what z is, interior, we go 8 minus 2 times 180 divided by the number of sides, which is 8. So 6 times 180 is, what did we get for 6 times 1? I'm sorry, not 6 times 180. Yeah, 6 times 180. Let's do that on my calculator. 1080 divided by 8, because there are 8 interior angles. So 135 is the value of z. And I'm sorry, I just realized I knew this didn't match my answer key for a reason. It's not an octagon, it's a hexagon. So instead of doing this with an 8, I should have been doing it with a 6. I apologize. So it should have said 6 minus 2 times 180 divided by 6. 4 times 180 is 720. So 720 divided by 6 gives us the interior angle, which is 120. So z is 120. Now what we have here with x is this angle is bisected, so half of 120 is the value for angle x, which is 60. Which, if these are congruent, it's isosceles, so that's 60 as well. So we have 60 plus 60 is 120. 120 from 180, because the sum of the angles in a triangle is going to add up to 180, and we end up with y also being 60 degrees. Okay, and the last one from our review, we have, so here we have a pentagon, which is regular, so all the interior angles are the same. So we have 5 minus 2 times 180, which is just 3 times 180, and we get 540. Now we divide that by the number of angles, so each angle is going to be equal to 108. This one angle is 2x minus 1, so we set 2x minus 1 equal to 108. Add 1 to both sides, and 2x equals 109. Divide by 2, and x equals 54.5. And that's your answer. Hopefully this helps you and prepares you for the test.